my only answer would be b equals 4. So then there's a couple more simplifies, a couple more solves. I think I'll just leave those for now. I think you get the gist of it, right? It seems like people get an idea of what that n factorial means and how to simplify things. Right, we're on to permutations. I did talk about what a permutation was yesterday, and we'll go to the pink book and we'll start doing some examples, but just to refresh your memory, permutations are, I like how they use that, a subsidiary of the fundamental accounting principle. So they're connected to the fundamental accounting principle. Because the fundamental accounting principle is just multiplying a group of numbers together, and that's what a permutation is. They specifically count the number of ways a task can be arranged or ordered, and they make use of factorial notation. Okay, first we're going to look at a permutation which is straightforward, and then we'll look at a permutation of n objects taken r at a time. All right, so I think I'm going to go to your examples book just to work through a few of those things together. Now, we did talk about permutations already yesterday. We started exploring them in our examples booklet. For example, it says, take the number of ways that the letters of each of these words can be arranged, like how many different code words. So spice is an actual word, but there are 120 different ways I can jumble those letters up, right? Same as this, there are 40,320 ways I can jumble the letters of the word goldfish. I'm not interested in if they actually make sensical words. We're just talking about passwords. So these are very simple permutations because there's nothing other than jumbling the letters up. We're going to see that the questions are going to get a little harder today because I'm going to add restrictions in. I'll give you an example of a restriction. A restriction might be, how many ways can I jumble up the letters of the word goldfish if, it always has an if in it, if the first letter has to be a vowel? You can see how that changes things a little bit, right? Makes it a little harder. So, but these are very straightforward. There are no restrictions. So I just want to bring attention to your attention to the fact that if a permutation has no restriction, you can use a formula to determine the number of permutations also. So we could have done those questions using a formula, and actually it's a button on your calculator too. But again, I'm just going to stress to you that that only works for permutations with absolutely no restrictions that are really nice and easy to use. So a permutation is represented in the formula by the capital letter P, stands for permutations. And NPR, the N and the R means something. So the N represents the total number of objects. And by objects, I mean letters, could be digits, it could be people, ordering people. So the total number of objects you are choosing from. And the R represents the number of objects chosen. Okay, so there's a difference there, right? If I look at my example here, let's say I wanted to create a 5-character PIN number from the letters, like I just did here, L-N-N-O-P, L-N-N-O-p. Okay, how many letters did I give you to choose from? 1, 2, 3, 4, 5. 5, right? How many did I want you to choose? Well, I wanted you to take all 5 of them, right? So you could have a permutation that's 5, choose 5. What if I said I wanted a 3-character PIN number from those 5 letters? Out of 5, I'm going to choose and order only 3 of them. Okay, so that's what that means. You don't always have to choose all 5. So the reason I have to not only introduce this is because for the easy permutation questions, it's very easy to use this formula. It's a button in your calculator. As well, the formula is included on your formula sheet. I mentioned yesterday this is the last section of formulas we have to talk about for this whole course. So you have a permutation formula and a combination formula, and then this is for the binomial theorem. But this is also part of your curriculum. You have to understand the formula and to be able to work with it. And this looks very similar to what we were just using, right, in simplifying and solving. So just be aware that the formulas are on your formula sheet. And I've printed it here. So for simple permutations, again, the instructions were how many ways can I jumble up the letters of the word spice if I use all the letters and jumble them up? Does anyone ever look at the, you know, in the paper, they have those little jumbles? Have anyone ever seen those? They have a little jumble every day, and they take 4 words and they jumble the letters. You know what I mean, right? So they might give you the letters out of order, but they want you to create the only word possible out of those letters. So you know if they give you 5 letters, there's 120 different ways they could jumble the letters up. Only one would be the right way. So if I want to jumble up and use all 5, so it's going to be 5P5. And you're going to have to play around with your calculator a bit to know how your calculator works. For mine, my NPR is right here on the second row. So mine works with, I put the 5 in first, then I select my NPR button. Mine comes out as capital P, and I put another 5. I hit equals, and I get my 120. It's a very quick way to do, so you don't have to, this is showing your work using the formula and calculator. This is showing your work the long way. This is obviously the more valuable way, because most of your exam is done without a calculator. But there might be a question on actually using the formula, so you should know how the formula works, okay? So that's the calculator. So I guess there's 3 ways we could approach this. Using the calculator button. So this is using the fundamental counting principle, FCP. And that's when we do our slashes and we do our choices. This is using the calculator. And then the last way is using the formula. Okay, so using the formula, 5P5 would be, okay, I'm going to follow the formula. This is my N, this is my R. Right? N factorial all over N minus R factorial, which gives me 5 factorial over 0 factorial. You can see why we need 0 factorial, right, to equal 1. So that becomes just 5 factorial over 1. I think some of you already had memorized 5 factorial yesterday. 120. Yeah? So you've got 3 ways of doing a permutation. These are great. This has its shortcomings, right? Because if you're on the non-calculator portion of a test or an exam, you can't use that button. This, you should understand how the formula works. And remember, you'll always have the formula on your formula sheet. I like this way the best, and that's my go-to, because they're not always going to be simple permutations. A lot of times they're going to have a restriction. So when they have a restriction, this is pretty much the way you have to do it. Okay? This allows you to have restrictions in it much easier than this way. Okay, so once again, goldfish, 1, 2, 3, 4, 5, 6, 7, 8. I could use a calculator. I've got 8 letters to choose from. I'm selecting and ordering all 8 of them. Can I help you, Marianne?
I'm just looking for a practice test for design graphic.
Did you find one? Should be in there. Yeah. And then formula would be 8 factorial, 8 minus 8. So that just gives me my 8 factorial again. Okay. So 3 ways to do the same question. Now, permutation, remember, is I've got a group of objects I'm selecting, right? Letters, they're usually letters or numbers, but they could be people that I'm ordering in a special way. But the order is important, right? Think of a permutation, the P for passcode or PIN number. Order is very important. You know how you can sometimes remember your digits from your password, but you kind of always forget the order perhaps? That's very important for permutation. Your computer won't let you log on unless the order is exactly there, right? That's what a permutation is. Okay, let's do a few more of these. We might end up doing some restrictions today. Okay, 15 people waiting in line to get into the library. How many ways can the people be arranged? I don't know why you'd want to do that, but maybe you do. So order matters. We're using all 15, correct? So what's the answer? How would I show my work for this one? Yeah, I could do 15p15, or I could do, I would have, I guess, 15 slots, but I know it's going to be that, I could just say 15 factorial, right? Either one, that's probably the quickest way. And it's a huge number, because that's the number represented by 15 times 14 times 13 times 12, et cetera, et cetera, et cetera. So this is the number we get, and quite often we might get these huge numbers. I don't know if that makes it a little brighter. But this number, I would just do this number to 2 decimals. So I would do 1.308 times 10. So look closely to the 12. That shows you how many different ways there are to arrange 15 people.
So I guess if the N and the R are the same value, it can also be represented as that value factorial.
Yeah. Yeah. Just like this guy. He, 5p5, oops. Yesterday we just represented him as 5 factorial, right? 8p8 was 8 factorial. Okay, this one might be a little harder to read. In how many ways can 6 people sit in a row of 8 seats at a movie theater? Let me just... Any ideas? Okay, so I'm going to give you a real big clue here, because this might be harder to understand. Note, N is always greater than or equal to R, right, in my NPR? It has to be, right? What did we define N as? N is the total group of objects you're picking from, and R is how many you pick from. So N always has to be equal to or greater than. So that means in this case, N is 8, R is 6, right? Yeah? So out of 8 seats, six people can arrange themselves I'll word it differently. There are 8 seats for 6 people to choose from. That's a harder one, I think.
How about 7 seats?
Huh?
How about 7?
They won't ever end up sitting in 7 seats because there's only 6 of them, right?
No, the N, yeah.
No.
8p6.
Yeah.
Yeah, 7p6 is it divisible?
No. No. Okay, what if we did this? Okay, so that's the formula way. So you could do, calculator back way and formula way. Let's try this one. How many decisions have to be made when they walk into the theater? How many decisions are being made? 8 decisions are being made by who? Who's making the decision? The people, right? So how many people are there? 6. So 6 people have to make a decision, right, on where to sit. Does that make sense? There are 6 decisions to be made, because the chairs aren't making the decision. I know this is a weird one. So there are 6 people who have to decide. Now, once one person sits down, the 5 left have fewer chairs to pick from. Agreed? So 6 people have to decide where to sit. So that means 6 decisions. 1, 2, 3, 4, 5, 6. Person 1, person 2, person 3, person 4, person 5, and then finally the last person, person 6, who's the most easygoing, I suppose, or the latest person, right? The first person walks in and they have a choice of, like the numbers that go in the slots are the choices, right? They have a choice of 8 seats. They're sitting down. The second person comes in, they only have a choice of 7. Okay, so this is not a factorial. It is factorial notation, but I'd have to use the formula, right? And I'd end up having some canceling going on. So this ends up being 20,160. Right? Now I could do this the formula way too. My 8p6 would be 8 factorial all over 8 minus 6 factorial, right? Which is 2 factorial, right? So that 2 factorial gets divided out, which leaves me with my 876,543. Right? I think that's a harder one to do when people go in and sit. All right, so in answer to what we were talking a little bit about before, sometimes we don't want to select all the objects. We were given this big group of objects, like maybe the principal says to me, Kim, select 2 of your students to come down and sit on a student advisory board. Well, how many ways could I select 2 of you from the group that I see in front of me? So sometimes we don't want to select all of the objects, or we can't. So that's okay, our formula is still usable. How many ways can you select and arrange 3 letters of the word saving? Calculate the answer using fundamental counting principle and the formula. Okay. So I want to pick 3 letters out of the letters of the word saving. How many letters do I have to choose from? I have 6 letters to choose from, and I'm going to select and order 3 of them, right? So 6, I'm going to use my calculator. 6p3 is 20. Okay, so that's using my calculator, not really using the formula. If I use the formula, it would be 6 factorial over 6 minus 3 factorial, which is 6 factorial over 3 factorial. Now this is what you learned how to do yesterday, right? Without a calculator, I would start by expanding the 6 because it's bigger than 3, so I'd go 6 times 5 times 4 and I'd stop, right? 6, 5, 4, because the 3 factorials cancel each other out. And that leaves me with 30 times 4 is 120, right? That's the second way. That's actually using the whole big formula and reducing down. Now, using the fundamental counting principle, that means you're just using the slashes. And soon enough I'll stop doing all 3 ways. I'm just kind of trying to expose you to show you initially. So, if I was using the slashing method, I want to only pick 3 out of the possible 6 letters. So how many slashes do I need? 1, 2, 3. How many choices do I have for the first position? Yeah. So what the fundamental counting principle does, it does all the like it just kind of shortcuts your formula, right? That also gives me my 120.
I don't want to walk all the way downstairs to grab my stuff.
Oh.
I'm in the library, right?
Oh. That's okay. Okay, next one. How many ways can a president, a vice president, and a treasurer be selected from a class of 25? Try any way you want, any method you want.
Please excuse this interruption. I just wanted to let those students know that deciding to wear a Christmas sweater today, whether it's ugly or not, come see Donna in the guidance office. We will be posting all pictures online, and we will be giving away 3 gift cards on Friday, I believe. So yeah, come see Donna in the guidance office.
Oh, shoot, I just grabbed, that happened to me today too. But I think there are some. Did you find some? I just didn't put a toss in there. Okay, what's your answer? 13,800. How many people agree? How did you do it, Eduardo? Formula or formula? So out of 25, choose and arrange 3?
Yes.
Okay, anyone else do it a different way? No? If I did the slashing way, it would be 25, then 24, then 23, right? Either way, I get 13,800. Okay, how many we're going to finish these up and then I'm going to give you a bit of work time. How many 5-letter arrangements can be made from the letters of the English alphabet? So we talked yesterday, there's 26 letters, without repeating any letters, okay? So without repeating any letters, once you've used a letter, you can't use it again, right? Is it a big number? So did you guys use the same approach again? 26 P5. Yep. So I got 7893600, right? Or I'd have 5 slashes, right? Or 1, 2, 3, 4, 5, 26, 25, 24, 23, 22. And I agree with you, this is way more efficient than the doing all the slashes. I'll just tell you again though, like the slashes will have their use when we do some more complicated ones with restrictions. And then it says, just so that you know how to maneuver and manipulate and recognize the formula, you might see one of these. It says, solve each equation for either n or r. So how would you solve a question like this? All it said was NP2 is 56. A couple of different strategies. I guess you could just trial and error it, right? Is there another strategy you might use, more formal maybe, or what would you use? Yeah, actually use the formula, right? So if I use the formula, you can go to your sheet, right? It's right in front of your formula sheet. I have extra formula sheets if you need it. this would be what? N factorial over n minus 2 factorial equals 56. So now it kind of makes sense maybe why we spent time yesterday on doing that simplifying. So see if you can solve for n. Okay, what'd you get for n? Are they both possibilities? Yeah. Which one's got to be tossed? -7, because -7 factorial doesn't exist, right? So you started with the top, because it's bigger than the bottom, and n minus 1, right? And then my n minus 2's will cancel, correct? Equals 56. So it looks like I'm going to get a factorial. So I get n squared minus n minus 56 equals 0. Sure enough, it's going to be 8 and 7, right? -8 and n plus 7 equals 0. Even if you know it's not going to be a good answer, you still have to state it. You still have to solve and then reject. 8 factorial works. All the factorials make sense. -7 factorial doesn't exist. Oh, what did I do? Sorry. N equals 8 is your answer. -7 doesn't exist, so you have to reject it. Okay. What about this one? Did you try that one? It's a little different solving for r, isn't it? I think. Let's see. So I'm going to use so I'll have 6 factorial over 6 minus r factorial equals 30. Okay, so our factorial formula is only defined for n. Like I guess the term that would come after 6 minus r factorial is 6 minus r minus 1, right? But I don't think that's going to get us anywhere, right? Any other suggestions for this? How to solve for r? Is there anything we can do? Rather than just trial and error it? What could we do? Can we clean this up at all?
Yeah.
What could we do?
How about we do like the first one?
This one? But I can't stream it out because there's no... I don't think that would really help me out much. I don't think I'll ever be able to cancel the factorials out, to be honest. What would you... Could we do anything, Joanna? To this other side? Okay, so let's do that. Let's do 6 factorial equals 30 times, just to get it on the other side, get rid of the fraction. Okay. Okay, Well, at least we got rid of the fraction. Anything else? Divide by 30? Can I divide 6 factorial by 30? We probably should change the 6 factorial to a number, right? What is the number? What is 6 factorial? What's 5 factorial? 120. What's 120 times 6? 720, right? So I have 720 equals 30 times 6 minus r factorial. Divide through by, once you, like if you just have a numerical factorial, you can always get a number, right? So then 720 divided by 30 is 24, right? Okay, so now, ladies and gentlemen, we are kind of stuck. Because there's no real formula, to be honest, for the r. Like, all we have is n factorial is defined as n factorial. So this, yes, would be 6 minus r minus 1. So I guess 5 minus r factorial. Like, do you know what I'm saying? Like, if I did the next one down, I could say this is 6 minus r. And then my next term would be 5 minus r, right? But it's that, I just can't see that helping me. So when you're solving for r, it's a little bit different. So let's think closely. 6 minus r factorial equals 24. So some kind of factorial equals 24. Does that ring any bells? Yeah, yeah, yeah. Okay, how did you think about it first? Where would you have stopped, Eileen? Where would you have stopped? Here? Okay, so how would Eileen, can you go up to the board and tell us your thinking? And then Eduardo can tell us his thinking. What's your thinking? Do you mind going up to the board? Okay, so Eileen already had it figured out here because she kept looking at me. You can erase everything. Let's erase everything. This is very good. Then I learned new ways to do things too.
Yeah. This is 30. So this gonna be this.
Nice.
Yeah.
Nice. Did you think of it that way too?
No, I think.
No?
I-
Did
I
you think of
thought
it that
yeah.
way? So
Because
you guys saw the 30 right away, and you saw the 30 just sitting in here, right? So the sheet canceled with whoever else. Did everyone else think of it this way? So she took the 30 right out. So then this is 1, right? So that's 1. So then she has this. She cleared all that out. She has 4, 3, 2, 1. Which she said, okay, well, this has to equal to each other, so it has to be 4 factorial. So 6 minus r has to represent 4 factorial, right? 6 minus r must be identical to 4 factorial. So how do I get 4 factorial in here? 2. Whoops, sorry. R must be 2, right? Which is the same conclusion you came to, right? A little later on. Yeah. So here, same thing. We got 24 equals 6 minus r. Well, what factorial equals 6 minus r? 4 factorial, right? Just from knowing a little bit about factorials now. So then 6 minus r factorial must be 4 factorial. Well, how do I get a 4 in there? R must be 2. So the r's are a little trickier. They things don't, your factorials don't cancel out. You sort of have to use common sense. You know? Okay, excellent work. I'm going to stop there. Our class was shortened today, and this book, another shortcoming of the book is it doesn't have any polynomial or permutations with restrictions. So this is a good place to stop, and I'm going to assign a big assignment for you, or lots of questions. I don't know if it's that big because some of the questions are super easy. So I'm gonna assign exercise 8.3, and there's 18 questions, if you can believe it. I'm gonna leave it up to you. Some of them are kind of repetitive, like for example, this one. I'm not sure if you actually have to. If you want to practice your formula work, you could punch this in the calculator. If you find this is not worth it for you, like you already understand this, you can just move on to number 2, right? This, at least you're doing something, you're solving for n or you're solving for r, so you play around a little bit like we just did. And then there's just a whole bunch of permutation questions. These are very straightforward, there's no restrictions on them. They're just really straightforward permutation questions. They just kind of give you an idea of the types of wording that you might see on a permutation question. Don't read too much into this. Facing same direction, we've never printed that in our examples that we do, but they're just making sure, it just says how many ways can 6 books be arranged on a shelf. They're just saying like how many ways can they be positioned. I think they just added this in because there are some students who say, well, you could flip them spine out or spine in. They're not worried about that. They don't care if they're spine out or spine in, okay? So I'm going to assign number 1 through 18. They're all very straightforward, I think. When you come back tomorrow, we're going to talk about permutations with restrictions or special cases. So we'll have to just exclusively use the examples in the book, and then I'll have another assignment for you just with some permutations with restrictions. Okay?